Okay, so in this video, we are continuing to find the critical numbers, intervals of increase and decreasing, and then relative extrema, which are maximums and minimums. But this time we're going to look at a little bit different example where we have sine of x plus cosine of x on this interval 0 to 2 pi. So I'm going to just jump over to Desmos. I'm going to graph that function. But remember, it's on the interval 0 to 2 pi. So I'm going to actually put some parameters on my function by using the curly brackets that are available on your keyboard. And this is basically how I'm going to define or restrict my domain for this function. So I want to restrict it when x is greater than or equal to 0, but less than or equal x less than or equal to 2 pi. You can get the less than or equal to signs on your keyboard or on the keyboard given here, or you can just type the less than or equal to sign and then hit the equal sign right after it. You can also get pi by just typing the word pi, pi. Okay, so we have restricted our domain. We've defined it here. Now I can see my function, and this will actually help me when I am looking for those intervals of increasing and decreasing to better evaluate where I'm going uphill and downhill and all that. So maybe let's do that first. Let's do part B first. Imagine you're on this roller coaster. You can only ever ride left to right. This roller coaster only moves left to right. Where are we going uphill? Where when I start, I'm going uphill in this first little section from what looks like 0 to pi over 4. And notice I can just click on that. If I click on it, it tells me where I'm at on the hill. So from 0 to pi over 4, I'm going uphill. So let's jump back over to our problem. And I'm increasing, this was part A, from 0 to pi over 4. Okay. Then it looks like I go downhill for a little bit, and then I am increasing from 5 pi over 4 to the end, okay? Notice if you click on the end, it's giving you a decimal, but we know what the end is. We've defined it because our interval starts at 0 and ends at 2 pi here, okay? So we are increasing, going uphill again from 5 pi over 4 to 2 pi. So I'm going to add that to my increasing 5 pi over 4 to 2 pi. Okay, now where am I going downhill? Where am I decreasing? Between those two values, between that peak and that valley, I am decreasing from pi over 4 to 5 pi over 4. Awesome. Now we just need to find our relative maximum and minimum, and we're going to use the first derivative test again because it's great practice. So again, we need to take our derivative. So let's take the derivative of sine of x cosine of x here. So f prime of x is equal to the derivative of sine is positive cosine. The derivative of cosine is negative sine. Okay, then we need to set it equal to 0. So we are setting equal to 0 our first derivative, and we are solving for x. How in the world do we do that when we have trigonometric functions? Well, I noticed that I can move sine over to the other side so that it's positive. So sine of x would equal cosine of x, if my pen will catch up. Here's the question we need to ponder. When in the world is sine of x equal to cosine of x? When is that possible? Well, let's just Google a unit circle. And we'll click on one. Let's look at our unit circle here. Where on this unit circle is pi of x, where is sine of x equal to cosine of x? Well, I can see here at pi over 4, they are both equal to square root of 2 over 2, cosine and sine. Also, if I make my way around my circle, at 5 pi over 4, they are both equal to negative square root of 2 over 2. So at pi over 4 and 5 pi over 4, they are the same, sine and cosine are. So let's jump back over here. Our solution then is pi over 4 and 5 pi over 4 when x is either of those two values. So we're going to use those to map our relative extrema. So we're again just going to plot pi over 4 and 5 pi over 4, and we're going to test values in our first derivative. So if this is f prime of x, then I want to test values before pi over 4, in between the two numbers, and then after 5 pi over 4. All right, so let's jump back over to Desmos. And let's actually just take the derivative of pi over 4 to see if it's going to give us, it gives us a value very, 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 very close to 0. So it actually doesn't calculate it quite exactly as 0. That's interesting. That basically, though, is telling you it is 0, which is funny that the calculator does that. All right, so let's find a value before pi over 4. I'm maybe not sure what pi over 4 is, just off the top of my head, so let's calculate it. It's about 0.7, something like that. What about 5 pi over 4? What is that value? Something close to 4. Okay, so we want to find f prime of a value that is less than 0.7. So maybe just 0. Let's see what that is. Okay, that is a positive value. Let's find a value in f prime that is between this 0.7 and something like 4. So 2 is between those two. That gives us a negative value. And then let's find a value with f prime that is greater than 4. So let's plug in a value greater than 4, maybe 5, and I see that's positive. So before pi over 4, that value of 1 is positive. So I'm going to come back over here. I'm going to chart that, right? It's a positive value. That looks like a T. Let's rewrite that. Positive. In between, it's negative. And after 5 pi over 4, it is positive again. Okay, so let's think about these sign changes. From increasing to decreasing, I'm going to have a max. From decreasing, going downhill, to increasing, I'm going to have a minimum. All right, so I will have a maximum at pi over 4 and a minimum at 5 pi over 4. We have to plug those values back in to our original function in order to find out what they will be. So I'm going to do just that, and I'm going to leave it without estimating it with a decimal value, okay? So I'm going to rewrite my maximum as pi over 4. This is a comma. And then plug it back in to my function. So my y value will be sine of pi over 4 plus cosine of pi over 4. And that is my entire answer. Okay, likewise, let's choose maybe a different color just so we can stand out here. For my minimum, I will have a value at 5 pi over 4 is my x value. So 5 pi over 4. And then my y value is sine of 5 pi over 4 plus cosine of 5 pi over 4. And that is my entire point for my relative minimum. Okay, so we have used the second derivative test the first derivative test to find our relative extrema.